Yeah, Jeff kind of asked me to throw something together for this week, and I was kind of thinking of road testing this anyway. This is going to be an interactive discussion today. I'm going to throw some stuff out there that I've gleaned from all of my years of working with radio automation, and I'd like some feedback from the group. Those of you who are in radio, those of you who aren't in radio, a lot of this stuff is common sense. A lot of this stuff is general knowledge that can be applied to, many different facets of broadcast when it comes to dealing with computers and human beings. Feel free to jump in while I'm doing this. I'll try to keep it as quick as possible. For those of you who don't know, I'm currently with DJB Radio Software. I've been here for about 6 years now. Prior to that, Director of Engineering for Evanov Radio, and prior to that, just, a radio guy. I've been on the air, I've been in programming, I've been in operations, I've been in pretty much every department of a radio station, short of sales. I got my start in the business thanks to automation. An automation system got dropped off at Centennial College in 1993. And I was fortunate enough to be able to work on the project to put it together. This was a very rudimentary media touch system. We used a CD jukebox instead of hard drives because hard drive space was worth more than a luxury car at the time. So I've kind of grown through that process. I've learned as I've gone along. I've been working with automation for over 30 years now. So I just kind of want to lay out in front of everybody some of the things that I've gleaned from that aspect of my career. Okay, so an overview of what we're going to look at today. We're going to look at some automation principles. We're going to look at networking, hardware, asset management, operation, redundancy, and assessing needs for an automation system in radio. The first lesson I learned when I walked into college is this simple phrase: garbage in, garbage out. That was courtesy of Don Gray, who was the program director of RTV at Centennial College back when I was a student there. It's a simple idea, but it is something that I've carried with me through this entire process. If you put garbage into a system, if you put garbage into any work, you're going to get garbage back out the other end. And that is essentially a universal topic. So that is just something that I want everybody to kind of sit with for a sec and think about, what quality of programming are we delivering to our end users, and is it up to snuff? Automation principles. Got some quotes in here, just kind of to set the scene a little bit. I am a bit of a music geek, so thank Bruce Springsteen for that. Radio Nowhere. Is there anybody alive out there? For a long time, automation systems took over the jobs of human beings. And what we ended up with was a jukebox on the air. Now that exists in a lot of places, and I need you guys to keep perspective on this. We're not talking about major market radio. We're not talking about the Bell Medias and the Rogers in Toronto and Vancouver and Calgary. We're talking about smaller broadcasters. We're talking about smaller markets. We're talking about what's that?
No. I was reading something. Sorry, sir.
Oh, okay.
I have to mute myself. Okay,
Thanks, Willie.
Okay, sorry.
We're talking about markets of 1,000 people, 2,000 people, 10,000 people, places where big corporations have come in, purchased those radio stations, and have essentially turned them into jukeboxes that have no live content. So, we need to remember that automation is there to provide 24/7 audio and control, but it doesn't replace people. It should be used as a tool to make content better. And I'm skipping ahead a little bit there. 4 key aspects to radio automation are scheduling. That's your music schedules, your traffic schedules, your automation schedules. Production, that's the audio content that goes into the system. Logic, whether we're taking in satellite programming from elsewhere or we're broadcasting out satellite programming, logic is a key component to this, having things wired up to the system and making sure that those commands are actually triggering the things that they're supposed to. And finally, play out, which is the audio content that goes out on the air. A good system should be able to run unattended or with minimal input and maintenance. You shouldn't have to have an operator watching your on-air system. You shouldn't have to rely on human beings to make sure that the system is doing what it's supposed to be doing in automating. Again, radio automation doesn't replace people. It should be used as a tool to make content better. One of the first things that I found in my early career, having an automation system where I didn't have to play carts and I didn't have to play CDs or records, was that I had more time on my hands to work on the background aspects of the program that I was doing. So I could spend more time on the phones. I could spend more time editing on reel to reels, albeit the content that we were using. When I was working at 680 News as an intern in the early days, everything was pretty much analog, but where automation came into play was the ability for us to be able to share news stories using the newsroom software and combine and coordinate all of our efforts to make sure that we had the best possible product and then everybody knew what everybody else was doing. So automation is not something that's just supposed to be stuck in a corner that runs your radio station. If that's the way you want to go about doing it, that's fine. But it should be a tool that allows your talent to be able to free themselves up from having to do a lot of manual labor and be able to provide better content on the air. Now, those same people that aren't being replaced by automation need to understand the system only does what they tell it to do. And this is something that I've run into a lot of times in my career, and especially since I got into the software business where I'm supporting customers. A lot of people out there don't understand how the system works. I'll give you a specific example. We had a cluster of 6 radio stations in a small town in Georgia. They're number one in the market. They're hugely successful with a couple of their formats, and their brands are, synonymous with quality broadcasting in that market. We went in and put in a system, and we had all kinds of problems off the bat because the staff there only ever knew how to push buttons. They were never taught how to, what effect it had when they made a change to a log, what effect it had when they made a change to a cart, what effect it had when they did anything that caused the automation system to change something. So I'll touch on that a little bit later in the operations section, but it's so critically important to teach your staff how it works, not just what they're supposed to do, but how the changes they make and the things that they're doing on a day-to-day basis affect the overall sound and quality of the radio station. And finally, the computers work for us, not the other way around. Okay. A lot of people, even engineers, will stand back and say, I don't know, the computer just does what it does. I don't know. We are the ones responsible for making sure that computer does what it's supposed to do. Artificial intelligence has not taken itself to a point where it can figure out what you want it to do. You still have to tell it, I want you to play this and play this and play this and do this and do that, and make sure that all of those elements are in place. Networking. Now, networking is a key component to anything that we do these days. There's so much in IT that has made its way into broadcast, and this is universal for radio and television and production and anywhere else. We have to know IT and we have to know networking, and there's some very basic principles in networking that seem to be forgotten when it comes to broadcast automation, especially radio automation, because again, TV automation systems are very complex, and there's a lot of video, and there's a lot of bandwidth needed, and there's a lot of isolation needed, and there's a lot of things that go into that. And not a lot of thought is given to this in the radio spectrum. It's just sort of like, oh, those computers are connected to each other. They should work. Why aren't they working? So thanks to the offspring, you got to keep them separated. Early automation systems that ran on 4-bit coax networks or 10 base T, we're a discrete closed network. What changed? Why did we stop doing that? Well, once LAN was standard in offices and studios, any old connection would do. Hey, there's a blue cable. I'm just going to plug it in and off it goes. Well, that doesn't work anymore. And it especially doesn't work when we're dealing with uncompressed audio. We're dealing with multiple systems in one place that are all trying to connect to the same server and serve audio around, move assets around. We're asking a lot of the network. So it's critical these days that the network gets separated and put on its own system, put on its own set of devices, and it's isolated from the rest of the traffic in the office. Again, this is another one of the things that I see all the time, even in mid-size and even some big markets. where no thought is given to this. Gigabit networking is crucial, but are you sure there aren't still some 10-100 resources in play? I'll tell you, time after time, we've run into this situation while trying to support customers that they say, oh yeah, everything's gigabit. And we look at the network adapters on the computers and yeah, they're gigabit. Everything says it's 1 gig or higher. But somewhere in a traffic office or somewhere buried in behind a bunch of, old computer technology in the back room is some 10-100 switch that something is running across, and it just drags down the network resources. So it's really important to make sure that we understand and we trace out all of the elements of the network to make it run. What's better, VLAN or a separate infrastructure? That's up to you. If you want to spend the money on managed switches, sure, go ahead. Set up VLANs. If you just want to put it on its own separate infrastructure and just set up its own LAN using its own cables, you can get away with any gigabit switch. There's lots of good product out there on the market that is inexpensive and easy to replace and maintain. We need to learn lessons from AOIP, the Wheatstone systems, the Livewire systems, the SAS systems, where multicast audio demands a closed LAN and no interaction with other networks. Now, this is a sticky point with a lot of radio engineers and a lot of guys who have worked with automation for a long time. The ruling theory has always been that your on-air machine should be an island, that it should be kept away from the outside world. It should not be allowed to talk to the internet. Well, unfortunately, we've gotten to a point now where a lot of our on-air systems need to see the outside world, whether that's for licensing or that's for the ability to be able to bring in weather information. As the AI movement continues in broadcast, we're going to need to be able to talk to external AI devices and AI servers. We can't keep our on-air machines completely isolated from the rest of the world. So when we get to talking about security, that's something that has to be taken into account, is that they can't just be an island anymore. They just have to be another part of the system, and redundancy can help you, keep yourself safe. Interaction with other networks. And I've said in this bullet point that no interaction with other networks. Well, yeah, okay. It can be an island, but it can still see the outside world. Global networking. It's no longer enough to just have a robust system running inside one building. In a lot of cases, even in smaller companies, there's the need to share content from market to market. There's a need to have global resources. There's a need to have everything interconnected from one market to another. So we are the world. Fiber is king. The days of DSL and cable are behind us. If you have not got the highest speed, highest quality, highest potential internet connection in every one of your sites, then you are doing yourself a disservice. Push the telcos. I know that at some transmitter sites that seem to be in the middle of nowhere, they're reluctant to do it. Push them, because even that guy who is the only person who lives on that country road out in the middle of nowhere where your transmitter site is, he would benefit from having high-speed internet. Push the telcos to put high speed in. Push them to put that fiber in, because it's good for them. And they're also getting kickbacks from the government for making sure that everybody in rural areas have high-speed internet. VPN, it's a necessary evil. And the debate rages on about whether software VPNs or hardware VPNs are more secure, what's better for your environment, what works for you. I don't want to wade into that debate. I'm going to say let the provider deal with the security. It's encrypted. Even, things as simple as zero tier that we use with some of our customers, or the old LogMe and Hamachi, it's encrypted data. It should be secure enough that you'll be able to move things from place to place without having to worry about somebody hacking that point. Obviously, you're going to want to keep that behind a firewall, but once again, let somebody else do the security work. You don't have to worry about that. But VPNs are very important for broadcast automation, and they're very important for being able to share resources quickly between markets. If you don't have a VPN in place, it's just going to add time. It's going to add time, and it's going to add complication, and it's going to make it harder for you to be able to get things from one place to another. So that brings up the next topic. How do we set up our networks internally? Are we the Pentagon? Are we doing what I call WAN peer? So the Pentagon, for those of you who may or may not know, the Pentagon is designed in 5 rings. Okay, so each ring becomes more important as you get closer to the center. And each one of those rings can be separated and segregated out. And a lot of networks have been set up that way, especially in big corporate environments where they say, okay, this ring out here can see the outside world, and these rings inside have to go through this gateway or this gateway and that gateway to be able to see the outside world. It's fine if you want to do it that way, but keep in mind, and we run into this especially in university and college applications, if the software can't see the outside world, you're losing out on resources. You're losing out on potential resources and the ability to be able to do all of the things that the software promises you can do. And again, very simple things like licensing, weather updates, being able to grab audio from a remote server. You got to figure out your network topology and be able to do it. Now, what I call WAN peer, that's where, you've got a bunch of net markets that are just basically connected together over a VPN, and Toronto is Montreal, is Calgary, is Vancouver, and you can see all the way through. But that has its inherent dangers too, especially when you run into situations where you've got ransomware or you've got malware that gets loose on your system. So I'm not going to delve much deeper into IT security. That's somebody else's job, but I am going to say one of the things that you need to decide ahead of time when dealing with automation, and especially when we're dealing with wide area automation, we're dealing with the idea of being able to share resources from market to market. You got to make sure your network topology is set and in place, and tell your automation provider how your network works before you get started, because we've got all kinds of tricks and tools and stuff to be able to work around it. It's not the first time that we run into this. And the last thing that we want to do is walk in the door and set up a system for you guys and have it not work because there's network security protocols and there's rings in place that are keeping us from being able to, to share information within even the same building, let alone between markets. Global security policies. Two-step is a pain, but it is an effective way of going about doing things. If you have domain controllers, if you have the ability to have remote access secured with a two-step, use it. Just use it. Whether that's they need to get a code from email or from a text message, or they've got one of the little dongles that, constantly refreshes the code, just use it. It's, again, let somebody else worry about that security. All you're doing is protecting yourself. Remote contributors. Everybody's working remotely now. I know that the trend right now, 5 years after COVID or 4 years, I guess, after COVID, is that everybody's kind of moving back to working in a physical brick and mortar location. But there's still a lot of remote contributors out there, and especially in radio. We see this all the time. My morning guy in Vancouver is also doing middays in Calgary and afternoons in Montreal. Okay, so, what is that person's studio? What kind of technology have you given them to be able to do this? We throw a codec into their place and they got a laptop and they can remote in. Okay, but how are they secured and how are they connected to the rest of your network? Treat them like internal resources. Do not treat them as being some, island out, somewhere in the sea where you're getting content from. And this is especially important when looking at, disaster recovery and the ability to have them be able to do multiple markets. Outposts. Let's talk about outposts. Air gap your transmitter sites and your offsite backups. We've seen too many times, and especially even in recent memory, where, some group who has got everything connected to everything. It's all, again, this is the WAN peer idea. It's all one big network. And suddenly they've got a ransomware attack. And before they even know what's going on, not only is all their stuff in their studios, all their stuff in their offices locked down, but they've hit the transmitter sites too. So now that sort of last mile backup doesn't exist anymore. Air gap those transmitter sites. One of the things that we recommend for our users is to put a separate automation system that is synchronized with your primary system out at the transmitter site. How do we do that? We have a program called Radio Spider. This is the only sales pitch I'm going to give you guys today. Our Radio Spider program allows you to be able to grab content and move it over the internet through secure connections. grab it off of an FTP, grab it off of your local file system, however you want to do it, and it pulls it down and inserts it into your automation system. It's universal, it's agnostic, it works with everybody's system. It's a great way to provide backup content at an air-gapped site without having to worry about having that VPN connection in place. All you need to do is put the FTP on the outside of your firewall, put Spider on the outside of your firewall, the transmitter site, have it grab the content, put it into your backup automation system, so that no matter what, that system stands alone from everything else. So when disaster happens, you're able to say, hey, we got this covered, at least until we figure out what's going on here at the studios. Offsite backups. I'm going to get into redundancy a little bit later on in the presentation, but offsite backups are also something that should be air gapped. And the quickest and easiest way to air gap it is to assign somebody within your organization to take that USB drive in their backpack home with them. Now, I know that creates all kinds of security issues and that kind of stuff, but it's just that last step in the process. Just make sure you've got a copy of your audio library. Make sure you've got a copy of your logs. Make sure you got a copy of your configuration settings. It's easy enough to do, and it'll save you a lot of heartache. One of our good friends, who's actually a member, had this happen to them recently, where the way they were able to recover from a ransomware attack is they had a server that had been in a water disaster at one of their sites, that had dried out and had just been sitting on the floor in the corner for 6 months. And they were able to open that box up, take the hard drives out of it, and recover their audio for their entire group, because it just happened to be sitting there. So you got to keep that kind of level of disaster in mind, that, if there's something available to you that, even if it's a little bit out of date, it will allow you to get back up and running without having to go through the headache of having to do everything manually. I'll give you an anecdote of how this used to be a problem back in the old days. When the hard drives used to fail back in the old days, it wasn't like you could walk into Best Buy. We didn't even have Best Buy at that point, Radio Shack, whatever. We couldn't just get a SCSI hard drive off the shelf. It was something that had to be ordered and sent to us. So anytime there was a failure, and I had this happen twice in the 90s at 2 different stations with 2 different automation systems, where there was a RAID failure and one of the drives went down, we all got called in for the weekends, and we had to play CDs all weekend, and we had to go back to manual radio all weekend. Nobody wants to have to do that. And most stations don't even have the resources to be able to do that anymore. So it's really, really important to keep that in mind, that one extra step of just air gapping by pulling a USB cable out of a computer and having that external hard drive sitting off to the side is critical to your operation. Let's talk about hardware. I picked this picture specifically because it's a reminder that nothing lasts forever. And, here's a pile of machines that probably date back to the early 2000s, maybe late 90s, early 2000s. We spent thousands of dollars on these things, and we ran them until they couldn't run anymore. Whether they were running Windows 98, Windows 2000, Windows XP, everything has an expiration date on it, and everything ends up as landfill at some point. Servers are servers. Workstations are workstations. Keep that difference in mind. Some workstations can act as de facto servers. Some servers can work as de facto workstations. But it's not really critical these days to have server level technology at every single desk. And I mean that from the standpoint of automation. I'm not talking about, you're not going to put a server at your traffic manager's desk, obviously. But a lot of the sort of, common thinking on this even 10, 15 years ago was, if I put a server in as my on-air machine, it's going to be more stable, it's going to last longer, and I won't have to worry about my on-air system being down because I put the server in. Well, I'll tell you what the mistake in that logic is. Servers take upwards of 6 or 7 minutes to reboot, which means for 6 or 7 minutes, when that machine has crashed or you had to do updates, you're off the air. Obviously you're going to have some sort of backup in the studio there, but your on-air machine is down while that's rebooting. Not the case with a simple workstation. Simple workstation can be back up and running in, a minute and a half, depending on how fast the BIOS boots and how fast the operating system on it boots. So it's just something to keep in mind. When purchasing, when looking at systems, especially for automation, favor preferred spec over minimum spec. A lot of our customers have some trouble with this, and maybe they're not, big market people, but it's really difficult to try to convince them that, the computers that they're seeing advertised in flyers and in mailers that they're getting from, refurb.io, are effective machines for running on air. I mean, sure, they meet the minimum spec, but how long is that machine going to last, and what kind of trouble are you going to run into with it? And you need to make sure that you're protecting, especially that resource, that on-air machine, the server that contains all of your audio and your logs and the infrastructure of your automation system. It's important to make sure that at least those two machines are up to snuff and can run for more than a year or two before you start having problems with them. Having said that, don't overinvest. It's really easy, again, to sit down and go, okay, I'm going to put a whole brand new automation system in here. I'm going to throw in top of the line everything. Well, top of the line everything today is going to be yesterday's news in 2 years. And then you're stuck with the investment of spending $3,500, $4,000, $5,000 on an on-air machine or on a production machine or on a traffic machine or a music programming machine because you were trying to make sure that you put your best foot forward. Don't worry about it. Budget and plan for a replacement life cycle. And make sure that while you're doing that, you buy a few extras. Extra computers, especially those workstations, are critically important. That way you've got something on the shelf that you can just replace. We're selling these little mini cubes right now. Great little machines. They, they retail for about $800 Canadian. And yeah, they're fully spec'd. They got all the bells and whistles. They're i7s. They've got 32 gigs of RAM. They've got NVMe 1 terabyte hard drives in them. They've got dual HDMI. They've got dual LAN. They're perfect for broadcast automation. But we're not kidding ourselves into thinking that these machines are potentially going to last for 10 years. No. They're inexpensive enough that if you need to replace one in a hurry, have one sitting on the shelf, talk to your IT guys, make sure that they've got, ghosting software in place, and just have it ready to go in the event that there's a failure. Because most of the automation assets now live on servers. They don't live on the on-air machine. The on-air machine is just an edge device that has an application running on it. And in some cases, that application might be a browser connected into the system. So, overdoing it on those edge devices is a fool's errand. Spend the money where it counts. Spend it on the servers, but make sure you've got extras. Budget and plan for a replacement life cycle. 3 years, 5 years. It's about all you're going to get. There are systems out there that we come in and replace that are 15 years old. They're still running Windows XP. They're running, 20-year-old software, and they work. And people they work. I don't want to change it. I don't want to go through that bother. The thing works. Everybody knows how to use it. Well, that's great, but that's an impractical way of looking at your asset management. It's an impractical way of looking at your systems these days. You need to keep up to date, which means that part of taking a proposal to your higher ups, to whoever's responsible for ultimately approving and spending the money, you need to make sure that there's a replacement life cycle in there. And again, extras, ask for the money now. Don't wait until it's too late. Don't wait until something breaks and then go back and say, hey, I need, $10,000 to replace something. And then go, well, you had your chance. Sorry, find something else. Laptops and broadcasts have kind of been, oil and water. Certainly people are, not comfortable using them in real life broadcast situations, but I'll tell you two things. Number one, they come with a built-in UPS. which is critically important, especially with the power grids being the way that they are. We have more power blips and more power failures than I think we ever have, and it's only going to get worse as demand increases. But the other thing is, as I discussed with those workstation devices, you're not using them the same way that we used to. We're using AOIP drivers. We're using virtual devices. We're using an application server, and all that unit is an edge device. And wouldn't it be cool if you could take that laptop to any studio, anywhere in your facility, or anywhere in any of your facilities, or even the end user's home studio, and plug it in, and it works the way that it would if it were a computer sitting in the studio. So don't discount laptops, and keep in mind that they do come in with their own built-in backup. Final thing about hardware: monitors, keyboards, and mice should not be overlooked. Don't put cheap ones in. You'll be replacing them every 5 minutes. Put in high quality KVM devices. It's also critically important to make sure that those resources are adequately supplied, so that you're not in a position where, hey, I bought 30 keyboards and mouse sets off of Amazon for, $200. Look, they're flimsy and they're going to break. Put quality stuff in. Digital asset management. I am going to point out that when I grabbed this graphic off the web this morning, that my initials are apparently a codec. That stands for adaptive multi-rate. Apparently it's a codec for VoIP. I don't know. It's not a vanity thing. It just happened to be in the picture, so I thought that was cute. I pointed out. Digital asset management. Little outcast for my homies. So fresh and so clean. Assess your audio assets. Don't leave anything to chance. We have had such a spate of issues with customers who have audio assets that are, in some cases, 20 years old, that date back to the dawn of digital audio. Stuff that was downloaded off of Napster, stuff that was downloaded off of LimeWire, stuff that we don't even know where it came from, codecs and sample rates and bit rates that we've never seen. And they're like, oh, well, it's just part of our system. Okay, well, guess what? Windows can only handle so many changes when it's trying to manage the upconvert, the upsample of stuff to WDM. We're even seeing issues where things that are 44.1 are conflicting with things that are 48K. And it's simply because Windows is trying to force all of us into a standardize on a format, standardize, trying to have all sorts of different sample rates, codecs. It's a nightmare to deal with. It's something that we have long, promoted, even in our own company, where we've said, hey, we can use anything, whatever it is, MP3, MP2, WAV, M4A, FLAC, yeah, OGG, throw it in there, we can use it. Well, that's not exactly a responsible way to go about managing your digital assets. Have a look at the audio content for your station. Have a look at the audio content for your server and check and see what's what. Because I guarantee you that even in the biggest companies in this country and the biggest companies in the world, there are probably pieces of audio in the library that have been there for 20 or 25 years that are old codecs and that are not up to snuff. Find them and replace them. Task your music department with doing that. Standardize on a specific file type. Compressed or uncompressed, that's up to you. Uncompressed music was the greatest thing in the world. It led to iPods and the music, the personal music listening experience revolution that has happened in the last 2 decades. But when hard drive space started to get cheap, broadcasters said, we're tired of listening to compressed audio on the air. We want waves. Let's redo our entire libraries in WAV. Let's go find CDs, PCM, WAV. Let's get this whole thing redone. Okay, great. Well, causes 2 problems. Probably more like 3, to be honest. Problem number 1 is all of that uncompressed audio now needs to be moved around the network. Remember what I said about networking devices and bottlenecks and separating LANs? Okay. If you want to run uncompressed audio, you absolutely have to make sure that your LAN for your system is separate from everything else. Number two, there's a lot of compression that goes on elsewhere in the chain these days. It's not just, the song gets played by the computer and goes to an analog chain and goes out to your transmitter site. There are a number of things along the way that could potentially compress that audio. Best foot forward, start with uncompressed audio, and then that way you're not feeding it garbage. Well, there's a lot of compression formats these days that sound better than the ones they used to. Again, if we're going to go through the bother of replacing the whole system, why don't we create a separate library of stuff that we've compressed ourselves using new algorithms and using new codecs, so that in the event that we don't want to have to deal with having to shuttle these, 70 meg files around, we can just use the uncompressed audio. Standardization on compressed or uncompressed also pertains to things like voice tracks and imaging and commercials. A lot of stuff is still getting serviced as MP3. A lot of stuff is, obviously, because of the size of it, it makes more sense for it to be compressed. Well, sometimes, again, Windows is going to have a hard time handling that change from, a 48K wave to a, 32K MP3. So just keep that kind of stuff in mind. It's just something to think about and to work on, and to just go back and audit what you have in your automation system. Clean up your audio libraries. Man, oh man, this is a frustrating thing to deal with. I used to hound our production department about getting dead audio out of the system. It bogs down resources. It bogs down the network. It bogs down the database. It bogs down every time you open the audio library on your on-air machine or a production machine. It bogs down the system because it's opening all of these files that don't need to be there anymore. This is critical. If the thing is dead, get it out of the system, because otherwise you're going to end up with gigs and gigs and gigs and gigs of stuff from 5 years ago, 10 years ago. Imaging for morning shows that don't exist anymore, commercials that, for businesses that went out of business before the pandemic. I guarantee anybody who is on this call right now, who's in radio, who goes and looks at the library in their own market, will find hundreds of dead commercials. Get them out of the system, put them in offline backup, put them somewhere else. Just get them out of your system. Our business is audio, so encourage all of your contributors, whether locally or remotely, to strive for quality over convenience. There is nothing I hate more than finding a compelling podcast to listen to, and podcasts are the worst right now. There's nothing I hate more than finding a compelling podcast to listen to and get aggravated by how bad the audio quality is, because the people who are doing it, in a lot of cases, don't know what they're doing. That should not be the case for professional broadcasters. There should be nothing that leaves your plant that sounds garbled, sounds like it was recorded on an iPhone built-in microphone, that sounds like it was compressed 15 times and stomped on by a compressor and stomped on by some other piece of processing before it went out. It's really, really important. And this goes for TV too. Okay. TV stuff is now making its way into personal devices. TV stuff is being streamed audio only. That old echoey studio sound with a couple of lav mics that, you never picked up on a pair of TV speakers. Well, guess what? People are listening to those on earbuds. People are listening to those on high quality Bose and Beats headphones. You don't want to hear that rattly echo in the background. Audio is our business. Make it sound good. I mentioned processing. How much processing is too much processing? Well, if it gets processed more than once, chances are it's too much processing. Radio stations, even TV stations, have audio processors, whether they're digital. There's a lot of great software-based stuff these days that, can handle that compression and the limiting and the EQ and, the final stage, the magic stage, where we add a little of this, remove a little of that, shine it up, make it sound great. Well, a few things that I'm going to point out about processing. If you know that that piece of audio is going over the air through an over the air processor, the only processing you should put on it is potentially a little compression, just to knock the highs and the lows out of it, you know? I'm a big fan of 2-to-1 compression at about -10. Well, that's how I used to run my analog processors before I fed an Optimod or an Omnia or an Aura, Wheatstone Aura something, just to give it a little bit of shape so that the main signal processor isn't having to do all the work. If you do more than that, then you're just as bad as the music producers these days who are over processing the audio that's being delivered to radio stations. They're over processing and over compressing everything. I mean, one of the things that's been a big change in on-air processing technology over the last 15 years is look ahead. Well, why does it need to look ahead? And why are we putting all this extra delay into the chain? Because it needs to find out whether or not that piece of audio has already been processed to the hilt and whether or not it should back off when it comes through the system. There's a huge difference between something that's produced locally as a commercial and a piece of commercial music that you're going to get that you're going to play on the air. It's ridiculous. I did a whole presentation to the Toronto AES about 5-6 years ago about this topic and about how things are being completely over processed coming out of the recording studios. It's at a point where, what's the point of having on-air processing? But the thing is that they want it to sound like that when it's being delivered to Spotify. They want it to sound like that when it's being delivered to iTunes. They want it to sound like that when they're listening to their own demo in their car. So any processing beyond that final stage of processing is probably too much processing. Now, I should put in a caveat here that, there could be not enough processing. If what you're doing is recording mostly voice and you're compiling that for, say, a podcast or a rebroadcast or something, have a producer who has an ear for this stuff take a look at it and take a listen to it and see if it could use a little bit of jazzing up, just a little bit of compression. Compression is not a bad thing. We talk about compression in terms of audio compression with music, and compressing things from wave to MP3, the great badness that has led to the revamping of vinyl because everybody wants to hear it, in its full range. Well, compression doesn't necessarily mean that we're going to take pieces of the audio out the way that an MP3 compresses a wave file. Compression can also just be something that gives a piece of audio some shape and makes it sound a little bit better, especially if you're listening to it in your devices, in your ears. Delivery platforms make a difference. And this is a good place to leave off when we're talking about digital asset management. AM versus FM, FM versus HD, radio versus streaming, codec versus STL. You have to be cognizant, and as the engineer, it's your job to be aware of where this audio is going ultimately. And you need to work with your production team to make sure that they're aware of where this audio is going. When AM stations first started simulcasting on FM in major markets in Canada, the audio quality was terrible. And I'm not saying that it's improved, enormously by this point, but it has gotten better because they realized the 8K or the 5K of bandwidth, analog bandwidth that AM limited your sound to, you could get away with murder. You could have noisy studios. You could have, bad codec content. You could have, scratchy cell phone noise, digital distortion that wouldn't be picked up when it came across on AM. But when we start broadcasting in HD, even though it's compressed, now you start hearing all the flaws. And this is the same for anything that's being delivered to streams. Processing your streams, processing the audio that goes through this, and paying attention to the quality of that audio will win more ears. That's an old radio expression about winning ears. We want to win ears. We want it to sound great. We want people to, be able to taste the radio. It's so important to make sure that you're paying attention to that now more than ever, because we're delivering it to so many different platforms, and it's going to sound different everywhere. But just one last thing, and codec versus STL. And this is something that I kind of threw in last minute on this page. Codecs are going to compress the audio, and some of them sound just as bad as a bad MP3. It's incumbent upon you, again, to make sure that you're putting the best possible product forward. STL, Studio Transmitter Link, sure, they've been digital for a long time. Sure, you can put a compressed audio stream into an STL. Let's look at this MPX over IP thing, okay? When I say STL, I'm talking about analog STLs that were, you had all the bandwidth in the world. You could just feed your analog audio into it. It was reproduced at the other end, and it came out sounding almost exactly as it did from the studio, with just a little bit of, wiggle on it, depending on the quality of that signal from point A to point B. Codecs compress stuff. So you got to make sure that you're using the best possible codec. My favorite is Opus. I really like Opus right now. I think Opus is a great codec. I think it sounds clean. I think if it's buffered properly and there isn't a lot of, jitter in the connection, Opus sounds pretty good. But again, maybe you're not able to use that codec, or maybe you don't have that available to you in the piece of equipment that you're using. Pay attention to how things sound, because it's so important. And this goes beyond automation. This is just, I know I've strayed a little bit away from, automation principles here, and I'm talking more about audio and radio, but it's something that's critically important. Garbage in, garbage out. If it starts sounding like crap, it's going to sound like hot crap by the time it comes out the other end. Operation of systems. And we're going to talk more about human resources here than we are about the actual physical operation of the systems. You guys know how to run a computer network. You guys understand how computers work. I don't need to sit here and tell you that, but I'm going to tell you some tips and things. I get by with a little help from my friends. It's really important to make sure that your entire staff, whether they work locally or they work remotely, are all part of the same team. And in the case of broadcast automation, in the case of making sure that product is being delivered as in the best possible way, it's kind of up to the engineers to quarterback that a little bit, because we're the last line of defense, and we're the ones that are going to get turned to and have to deal with it when something goes wrong. So be a little proactive about it. Learn all you can about automation, from scheduling to on air. Our job doesn't end at getting the system functional. Okay. You have to know how the system works. You have to know how all of the various parts and pieces interact. Schedulers, playout systems, production, everything. You need to know how it all interacts. Synchronize everything. Clocks and logs have got to line up. If they don't, you're going to have all kinds of problems. And what I mean by that is your traffic log, your music log, and your automation log all need to be in sync. Because if they're not, then commercials are going to end up in the wrong place. Music isn't going to line up properly. And, eventually you're going to end up with a bad product on the air, or the wrong thing playing at the wrong time. Encourage key staff to meet regularly to discuss issues and solve problems. This was something that I used to do. I would bring the traffic people and the music people in. We'd have a lunchtime meeting, get it catered, have some pizza, whatever. And everybody would sit down with their clocks, and we would just compare them. Oh, I see you've got a break here at 15. Okay, we don't have that break in the music log. Okay, well, let's fix that up. I see you've got an automation code here at 45. That's not in the automation log. Okay, then let's make sure that that's, taken care of. And that's how you solve a lot of those problems, is just having people sit face to face. And you can do that on Zoom. I mean, it doesn't have to be an in-person meeting. It can just be something you do on Zoom. Engage with everybody. Anyone who touches an automation system is a resource and a potential point of failure. They're a resource because they can tell you what works and what doesn't work. They can tell you how things could work better, or how workflows could be done differently to make the system function better as a whole. But they're also a potential point of failure. Training is key. Don't leave anything to chance. I keep using that expression. If the people who are using the system don't understand how the system works, and don't understand the impact that they're having on the system, by anything that they do, whether that's scheduling a log or, changing things on the fly on the on-air system or importing a song or a pre-recorded program. If they don't know how A gets to B gets to C, then they're going to have no concept of what happens when something goes wrong. It's really critical to make sure that everybody who touches an automation system understands at least the principles of how it works. Cross-train people. No one person should be solely responsible for any one part of your automation system. I know that protecting our jobs is something that we do now more than ever, but let me tell you, nobody's job is safe in this environment. With the way things are changing, with the way things are going, nobody's jobs are safe. We have to cross-train people, or else you're going to find yourself in a situation where only Shirley knew how to do this. And everybody else has to scramble around to figure out how to insert the traffic. So it's really, really critical. And again, we as the operations people, the engineers, we have to take the lead on this. I realize that I'm running a little bit long here, so I'll just try and move along quickly. Anybody got any comments today to this point? Have I bored everybody? Is nobody listening anymore?
Not boring at all.
What's that?
I said not at all boring.
I'm listening.
Great. Well, hey, thanks, Willie. You always got my back, buddy.
I want to start me, but I let you go.
Let's talk about redundancy. Okay. We live to survive our paradoxes. Thanks to the great Gord Downey for that one. How much backup is too much backup? You could back up yourself into a corner. You can create so much backup that you've forgotten where everything is or how old this backup is compared to that backup. Or you can put yourself into a synchronization loop, which are always fun, where this thing's backing up this thing, which is backing up this thing, which then overwrites the first thing you put in, and you create a mess for yourself. How much backup is too much backup? Let's be honest. How many copies of things do you really need? And what's the critical component to the backup of your automation system? Your audio assets, your logs, and configuration files. Everything else is just software. Everything else is just install an exe, map it to a drive, map it to a network resource, point it at a database, point it at the audio, database, logs. Those are the things that you need to keep backed up. And you don't need to have 6 copies of the same backup. Most of the automation systems out there, including our automation systems, will do a live local backup for you. So you've got it on the on-air machine. So in the event that the on-air machine becomes disconnected from the network, it fails over seamlessly to the backup audio and the backup SQL database that's on the on-air machine, and it just keeps running. And then when the network resources come back, it goes back to those network resources. We've even put in a system with our new DJB zone system that allows you to have redundant servers. So if you lose your primary server in market A, your on-air system can go and pull from market B. But getting carried away with backups is something that I've seen a lot of people do. And again, like I say, you get into this loop where you've just got too many copies of the same thing over and over again. And it's eating up resources because every time it copies, it's eating up bandwidth. It's trying to do too much. Demystify cloud. I've had so many conversations with people about cloud, even engineers, even people who are very bright, who think that cloud is this, either dangerous place where we can't put anything, or it's this mythical place where files go to live off in the ether somewhere, and when we need them, they're there. Cloud is just a word for a server at somebody else's rack. That's all it is. So you want to do a cloud backup? Fine, do a cloud backup. You want to put a cloud-based system in? There's a couple of them on the market that pull your audio and pull all your resources to and from the cloud. Sure. It's there. Use it as a resource. But be wary of the fact that, like anything else, it is not in your building. It is not something that is tangible that you can touch. And if it gets disconnected, if there is a failure, you need to make sure you got a backup somewhere. So just demystify that cloud thing altogether. Create single points of failure rather than multiple points. This is the point that started my conversation with Jeff last week in Ohio. about putting this presentation together. We were talking about, you know, how backups upon backups upon backups and, you know, backup systems. And, you know, if this goes down here, then we're going to switch over to this. And if that fails, then we're going to switch over to this. And if that fails, we're going to switch over to this. Creates multiple points of failure. Isolate it down to single points of failure. Nobody wants to be off the air. Nobody wants to have a system failure. Nobody wants to get that call at 3 o'clock in the morning that something is down and has to go fix it. But wouldn't it be so much easier for you if you knew that you'd created single points of failure? Think of it like a fuse or a circuit breaker. When something fails, that one little piece of copper or zinc burns. That's it. You replace that. If it burns again, you know you got a problem on the other side of it. If it doesn't, then you're back up and running. No foul, no faults. Make sure that those single points of failure are built into your system. Don't go crazy with redundancy. Centralization is great, but what if that's the failure point? And this is where I talk about making sure that you've got local backups. Think about this stuff ahead of time. Talk to your automation providers. Talk to the people who do this for a living. Learn from them about how other places are doing this. Because when that centralized thing fails, not only do you have one market off the air, you could have 10 markets off the air. If it's a link in the chain, it could take your entire network down. You need to make sure that you are able to decentralize as quickly as you centralize. Now let's break away from talking about the sort of engineering side of it and let's talk about the human side of it. Can your audience rely on you to be there in a crisis? We're sitting here again on the verge of another historic hurricane hitting Florida. Florida is about to get drowned in the next 24 hours. I know a lot of people in radio in Florida, and I know a lot of them spend a lot of time building in redundancies to be able to deal with this. We have a customer in Panama City, Florida. They're the local state college. And after a hurricane 6-7 years ago, they were tasked with putting a backup system in place that meant no matter the level of the disaster, the station would be on the air and the local emergency services could take over the airwaves and broadcast to people. And what they did was they built in a triple set of redundancy. There's the studios, and it can operate as an island. There's the transmitter site, and it can operate as an island. And there's an emergency services bunker that can also operate as an island that's actually attached to the transmitter site. So short of the tower falling down, and even if it does, they have a standby tower. They are able to keep that signal on the air. And that's what your audience needs. So don't paint yourself into the redundancy corner. Don't create those multiple points of failure when trying to assess the best way to automate everything and centralize everything. Use the physical and human resources at hand. Remote contributors, transmitter sites, they can be a lifeline for you. Have a computer sitting out at the transmitter site. Have a microphone sitting out at the transmitter site. Put systems in place that allow you to have that air-gapped system that's just sitting there waiting for the eventuality. Chances are your transmitter site's got a generator and backup power because there's other resources on that tower than just you. There's cellular, there's police, fire, and ambulance. Make sure that you've got standbys at the tower site. And again, your human resources, those remote contributors, the guy that sits in the basement and does his morning show from his house, he's got a codec. Make it so that he can dial directly into the transmitter in the event of an emergency. The studios are down, he can talk to the transmitter site. And he's got an automation system in front of him that allows him to continue broadcasting as normal. Last thing on redundancy, don't forget analog. It worked for the first 100 years. Why wouldn't it work now? I mean, again, that veers away from the idea of, automation being everything. But, you know, again, plug a microphone into a processor and have something that can go on the air in the event of a large scale last ditch emergency. Assessing your needs. And this is the final bit of this presentation. Every time you sit down to design a new system, it feels like the first time. Our industry is changing faster than the technology can keep up with it. What we needed last year is ancient compared to what we need today, let alone tomorrow. You're not alone. Everybody is dealing with the same thing. Everybody is dealing with centralization, virtualization, diminishing budgets, diminishing revenue, stations shutting down, being sold, jobs being cut. Everybody's dealing with the same issues. So ask questions, talk to people in your organization, find out their pain points. The people who use your automation system are your best guides. And don't follow the pack when it comes to assessing your needs. Shop around, see what's new, see what's emerging. It's not that difficult. Everybody knows lots of people in this industry. It's also a critical point to say that if you have, I mean, SBE is a great resource, but if you're able to get to WABI, get to CCBE, get to NAB, see what's out there, because you never know. One of those conversations could turn into that solution that you don't know you need yet. Take risks. Okay. There are so few of us left in this industry that it's so critically important that we take some risks. Don't just do what feels comfortable. Don't just do what we've always done. Take risks, build systems, make things happen out there. Because if you don't, then when something does fail, you're going to wear it and you're not going to be able to get to it in time. You know, I'm seeing so many clusters of stations on both sides of the border where there's one guy who's responsible for 500 miles of stations and transmitter sites. You know, so if you see a new piece of technology that looks like it's going to work for you, take the risk, put it in. It's the worst thing that can happen. And find partners. Many companies are all too happy to take your money and then give you corporate attitude instead of solutions. One of the things that I pitch to my customers is that we're here to work with you. We're here to partner with you. We want your feedback and we're going to develop things for you. It's important to not just, you know, say, well, you know, this big guy that everybody else is using, we're going to run off and use them because everybody else is using them. Well, you know, there's little companies out there that might be the key to solving your problems and helping you through these situations. So just, again, you know, look around, think about different ways of doing things and think about different ways to look at automation. Automation is not just a computer that runs audio anymore. It can do so much more for you. Your automation system can actually take control of a lot of your resources. If there's IP-based logic closures, even physical logic closures, you can use your automation system to do so much more than just play music and spots. It could be a lifeline for you, especially in markets where you don't have anybody and you don't have any live bodies. Anyway, that's it for my presentation. I hope I didn't drone on too long. Any questions?